Welcome to Kitek Technologies Private Limited. This is the demo of Antenna Trainer Kit model number 8001. This trainer is designed for study of different concept of antenna, fundamental of antenna and radiation pattern of antenna. The trainer consists of main unit and transmitting mast, receiving mast and RF detector, matching stub, current probe, BNC to BNC connector, different type of connector for connecting antennas in horizontal and vertical polarization, 21 different type of antenna for study of radiation pattern, and one antenna detector. The main unit consists of RF generator which generates frequency of 750 MHz with its power adjustment is given with this knob. Modulation generation which generates sine wave of amplitude and fixed frequency of 1 kHz with amplitude adjustment is provided with the help of pot. A switch is given to select the internal modulation or any external input is given for modulation. Direction coupler is provided with the pot adjustment to measure the forward power generated from generator to antenna and reverse power generated from antenna to generator. A female BNC connector is provided on which the transmitting mast will be attached. A goniometer with a reading from 0 to 360 degree is provided. A display is provided for measurement of power in microampere. The receiver part consists of receiving mast and RF detector which has BNC connector on which the detector antenna will be mounted. This RF detector has inbuilt power supply from battery, no external power supply is needed. A level potentiometer is given to adjust the power. Now we will assemble this trainer for further experiments. For that, connect the transmitting mast which has male BNC connector on the female BNC connector provided on the trainer. Connect any antenna on this transmitting mast. For example, here we have connected simple dipole lambda by 2 antenna. Now connect detector to the receiving mast. Connect male BNC connector at the top of RF detector. Connect the detector at the BNC connector provided on RF detector. Now make sure that the zero of the transmitting antenna is pointed towards the receiver. So this is the feeding element and this is the reflector. The feeding element should always point towards the transmitter. The antenna connected on the transmitting mast should point towards the detector, and make sure that both the height of both transmitter and receiver is matched. You can do that with the help of this. Screw is provided at receiving mast to lock the receiver at any position. Now the setup is ready to plot the radiation pattern of different type of antennas. Now we'll plot the radiation pattern of simple dipole λ/2 antenna. First, turn on the detector with the switch provided on it. Make sure that initially it is showing 00 reading. Now connect power supply to the transmitter. Turn on the trainer. The display is showing 85. Make necessary adjustment from RF generator, direction coupler and modulation generator. Keep RF generator at maximum and modulation generator at maximum and switch SW1 towards upper side, that is internal modulation, and directional coupler switch towards forward side. Now adjust the current up to 100 microampere. Now accordingly adjust the detector value at 3/4 of the transmitter value. Here adjust it at around 75. (70 to 80), it is okay. Now make sure that the antenna is pointed towards receiver and it is at coinciding with the 0. So now the angle is 0. Now rotate the antenna from 0, 10, 20 and see the effect on receiver. As we are going from 0 to 90, the reception is decreasing, and from 90 to 180 again the value will increase. Then from 180 to 270 the value will decrease, and from 270 to 0 it will increase again. The reading of the detector is in microampere. Student needs to convert this microampere into dV microampere with the conversion chart given in the manual, and they need to plot the radiation pattern on polar graph, taking the reading at forward current with a different angle and what is the detector current at that angle. This is in horizontal polarization because detector and transmitter both are in horizontal. Now we will see the effect of the distance between receiving mast and transmitting antenna on the detector. As we increase or decrease, the changes will be there. If we increase the distance between transmitter and receiver, the received signal will be of less strength, and if we decrease the distance between transmitter and receiver, the value of detection will be more. Now also the effect of interference. If by mistake anyone kept the hand or anything in between transmitter and receiver, then the received signal will be less. So this is the effect of interference. For demo purpose only we have kept all the antennas here, but while performing the experiments on this trainer, keep all the antenna away from it and use only the antenna which radiation pattern you want to plot. Also keep mobile phones or any other electronic equipment away from this setup to avoid the interference between this trainer. The strength of the antenna is different for different type of antennas. For this antenna, that is simple dipole lambda by 2, at 0 position the value is around 60. Now we will connect other antenna and we will check the value or gain of that antenna, but before that we will keep all other antennas away from this setup. Now connect folded dipole lambda by 2 antenna in place of simple dipole lambda by 2. Remove it from the transmitting mast and connect folded dipole lambda by 2 antenna. And measure the gain. At 0 position, the gain of this antenna is more than 140. So now adjust the pot and keep it at around 75. to 80, it is okay. Now plot the radiation pattern of folded dipole lambda by 2 antenna by rotating the transmitting mast from 0 to 360 degree in step of 7 angle and measure the gain on RF detector. From 0 to 90 it will increase, from 90 to 180 it will decrease, from 180 to 270 it will again increase, from 270 to 0 it will increase. The gain of this antenna will increase and decrease depending on the angle. From 0 to 90 it will decrease, 90 to 180 it will again increase, 180 to 270 it will decrease, and 270 to 0 it will again increase. Student need to take the reading and convert this microampere into dB microampere and plot the radiation pattern of this on polar plot. Similarly, student can plot the radiation pattern of all other horizontal polarized antenna in the same manner. Now we will see the vertical polarization and horizontal polarization of the antennas. For that, remove the detector antenna, connect L-type connector at detector. Now connect the detector antenna to this L-type connector and keep it in vertically polarized. Now the transmitter is horizontally polarized and the detector is vertically polarized. We can see that the gain is reduced in detector. So when transmitter and receiver are not in the same polarization, the gain will be less, and when transmitter and receiver are in the same polarization, the gain will be high. Now plot the graph, rotate and see the effect on this. The received signal is minimum Now remove this horizontal polarized antenna and connect vertically polarized antenna. For example, slot antenna. This antenna will generate power in vertical direction. Connect it at transmitting mask. Point it towards the detector and transmitting mask should coincide with 0. Now we can see that the gain has increased. Both transmitting antenna and receiving detector are in vertical polarized. That's why the gain is more in this. The receiver gain is not up to that mark, so adjust it at around 70 to 80 or in between that. Now plot the radiation pattern of this antenna. Rotate the transmitting mask from 0 to 360. As the antenna is rotating from 0 to 90 degrees, value is decreasing. From 90 to 180, the gain will again increase. From 180 to 270, the gain will again decrease. And from 270 to 0, the gain will increase. Thus we have plotted the radiation pattern of vertically polarized antenna, that is slot antenna, where the detector is also vertically polarized. Thus we have performed the polarization test experiment given in the manual. Now we will see the matching stub experiment. For that, remove the detector, because we need the detector in horizontal polarization. Connect the detector in horizontal polarization. Connect the antenna on transmitting mask. But before that, connect T-type connector at transmitting mask. Connect the antenna on this. For connecting antenna, connect BNC to BNC male connector. Now connect the antenna on this. This is Yagi-Uda folded dipole 3-element antenna. It has director, and director should point towards the receiving mast and detector. Then the middle part, its feeding element, and this is reflector. Now connect the matching stub. This is the matching stub for antenna trainer. Connect one end of the BNC cable to the BNC connector provided on matching stub. Other end to the T-type connector on the transmitting antenna. Make sure that the height of transmitting mast and receiving mast is same. Adjust the detector on receiving mast. Now adjust the forward current at around 100 and detector current at around or in between 70 to 80. Matching stub is used to match the impedance so that maximum power is transmitted. Now measure the maximum power. It is 100 at this time and the switch is on forward position. Now in reverse it is close to 30. Now put the switch in forward and slide the slab on matching stub to get the maximum power. Slide the slab to get the maximum power forward. Matching stub. Now check the forward current. It is 105. Initially it was 100. Now check the reverse current. Put the switch in reverse. It is 27.6. Initially it was 30. So the match stub, the impedance is matched and maximum power is transmitted at this point. So the detector will detect the maximum at this point. For SWR measurement, measure the maximum current in forward direction and minimum in reverse direction and put it in the formula to calculate the SWR. This way we have completed the modulation setup, matching index, matching stub for antenna setup. Now we will see the experiment of current probe sensor. For that, remove the matching stub. An electromagnetic field is generated towards this antenna. To measure this current, we can use current probe sensor. Connect. This is the current probe sensor. This is current probe antenna side. Connect the current probe antenna side on the now the resistor is connected. Now measure the voltage across that resistor and thus we can measure the current. Initially the matching current probe is towards the antenna. Now measure the current. Here we are measuring the voltage. It is in DC. Here it is 147. Now slide the current probe towards the edge. Now measure the voltage at this position. Change the position and keep it at the edge. Now measure the voltage for different position. It's 96. So as the position is away from the antenna, the voltage decreases and we know the resistor, so we can measure the current. The voltage measured here is in the range of millivolt, so make sure that your multimeter is at 200 millivolt setting. Thus we have completed the current probe sensor experiments. Now we will see the experiment of modulation test, but before that, remove the current probe, remove the antenna, now connect simple dipole lambda by 2 antenna, match the height of transmitter and receiving mast, keep the forward current at around 100, detector value in between 70 to 80, connect CRO positive to the red terminal and negative or ground to the black terminal, and observe the waveform on CRO. This is the modulation test. Rotate the antenna and check the variation in waveform. As the gain of the detected signal increases or decreases, the modulation value also increases or decreases according to that. Thus we have performed the modulation test. Now we will see different type of antennas provided with this trainer. This is Yagi-Uda simple 5 element antenna, out of which 3 are director, active element, and this is reflector. This is ground plane antenna. It is provided with 3 rod of different length. This is director, this is active element, and the last one is reflector. Yagi-Uda folded dipole element antenna. It is same as simple dipole, 3 director, then feeding element or active element, then reflector. Always keep the director facing towards the receiving mast and detector. This is helix antenna. Cut paraboloid simple dipole antenna. In the same way, all other antennas detail is given in the manual. The trainer comes with 2 kit antenna, kit A and kit B. User can use these 2 kit A and kit B antenna to make their own antennas. This way we have completed the demonstration of antenna trainer kit model number 8001. Thank you.